Um, Good afternoon, ladies and gentlemen. My name is Percy, and I would like to also thank my postdoc, Dr. Weiwei Chen, and Professor Ioannis Brilakis for helping me throughout this project. Today, I'm going to show you a little bit more about analyzing the conditions of road assets with a network thinking. I'm from the University of Cambridge, and my project is on digital twins of roads. And this is sort of the first step of a big episode. Let's put it that way. So my motivation of doing this project, as you know, we've got loads of roads around the world and in the UK and many places, with all the kinds of requirements that we need to meet by 2050 or with a very not too distant time frame. We actually want a lot of step changes of surface quality. Environmentally, we want net zero by 2040 for the road network. We want to make the roads zero harm by a not very distant future. We also want to help the UK to use road network to push up the economic initiatives of leveling up or some other economic initiatives. Each of them are not easy on its own. Combined is next to impossible. But we are sort of seeing how to get this very difficult task to be done with quite a bit of digitization. Hopefully we can basically move all the things, well, a lot of the things into the digital world. So we think about what is the optimal strategy and put the most optimal strategy onto the roads so that the boys on the street, on the roads will be maintaining the assets with the shortest period of time that is making the people who do the work or people who use the road more comfortable. So we are seeing how digitizing the network will be something that will help. And the first step of this will be to study the conditions of road assets, and particularly with a network thinking, which I will illustrate to you why I'm doing this. The state of practice. So road is not something new. Even for maintaining motorways in the UK, we have already got 70 years of experience. But the problem is we have lots of documentations, and really a lot, meaning there is a hierarchy from the national level. For example, in the UK, we have the design manuals for roads and bridges, which sort of puts down the requirements of what each road was like. Or what kind of asset, like how you need to maintain the assets and so on. Down one level is the county, so sort of like the provinces or states. They would be giving some more concrete discussions about if this defect happens, do that. If that defects happen, use another maintaining strategy. And this will be sort of the county level kind of design, like maintenance manual instructions. Further down the line, we also have some very learned professional institutions who write or research about particular kinds of road assets with a lot of documentations. At the moment, there are a lot more indices on pavements reporting on aggregated length. So, for example, if my job is to maintain a 5 kilometer long road, you will be reporting an index of like IRI, road condition index, RCI, etc., with the choice of the jurisdictions on every 100 meters. So that's what we have for pavements these days. And at the moment, defects, the pavements will be detected every year in the UK. For other assets, the general inspection routine will be happening every 2 years. A detailed inspection actually have a person telling where is rusting or which bolt is gone. These kind of inspections are done every 6 years. And they are done typically in an inspection form, tick or cross. Defect, no defect, that kind of style. And the follow-up actions will probably to take the most critical repair for the section. So previously I mentioned about detecting 5 kilometers of road, and if there is one section that is requiring that critical, like say, overlaying, the relaying of the entire blacktop, then you probably replace the blacktop for a considerable length rather than just the 100 meters. So the issues is that we know a lot about the roads, but they are in separate places. The documents are scattered, and we need to find, okay, if I want to look at the street sign, I need to look for that book, and for that instruction, I need to look for the county level instruction manual. But why am I doing the things required by the counties? I need to find something else. It's quite scattered at the moment. And more importantly, if there is one thing I want to tell you today, road is not just the pavements. There are loads of things. Even just on the pavements, we've got the lane markings, we've got the studs, we have got the joints between the concrete panels if it's done by concrete pavements. And there are a lot more interesting things outside the pavements. We've got the central median, we've got the side barriers, we've also got some infrastructure that is not strictly speaking the road work itself, but is still in the road environment nonetheless. So the complexity of road assets is something that we need to concern about. And finally, it depends on how granular we want to tell the defects. Do we want to know the RCI for every 100 meters? Or do we actually want to know where each crack is so that later on when we go fix them, we actually can locate each of the defects? So it really depends on what you are trying to do. And the granularity is something that we need to think about. So this is the issue of the state of practice. A lot of people have done research because we have got roads for so long. First of all, what assets do we actually have on the roads? So I'm sure my learner colleague will tell you her research about what assets were there in a road environment later on in this conference. And I'm sort of modifying from her work and look what assets do we have from a defects detection perspective. For example, like a street sign, like a stop sign, or like warning signs or hazard signs, those will be different assets, but in the maintenance, they will probably be classified as the same type because they are regulatory and warning signs, which have sort of a same actionable threshold. When things go worse than the threshold, then they need to take the action. So that's how I think about the categorization. There's also another dimension of thinking how to maintain road assets at a component level and a system level. A component level will be something like by professional institutes to research on electric equipment, like the one in the middle, by the Chartered Institutes of Highways and Transportation. There are also other research on similar kinds of granularity. So, for example, for traffic calmings, the humps and bumps and the road cushions, someone actually done a research on like why these things have done and like a good practice of it. And obviously, there are a lot more about the materials and different like elements of the roads itself. They'll be at a component level. The system level will be something like a road risk and assessment or a FAMICA analysis to think about what kind of defects are we having the most, where are we suffering the most, and how are we going to improve, what kind of assets or what defect are we actually targeting. And so to move on from that, and there will be some sort of state of research of sort of categorizing road assets or defects in a more systematic manner. And finally, is the asset decision trees. So far, a learned colleague, Jorgis, has made something for asphalt pavements, and there's another writer, Haas, who has written something for pavements, but so far, the developments on asset decision trees, particularly for non-pavement assets, is still something that we can do a little bit more. So my methodology goes as such. 5 classes of information at once. What assets and what defect from the assets I want to look at. So at the two ends, I also got the repairs, the short-term like-for-like repairs. And on the other end, I want to not solve the symptoms, but sort of treat these disease, put it that way. So think about this as a road doctor. When a patient, like an asset, go into a general practitioner's clinic, they probably tell you all the symptoms. I have chesty cough, I have a headache, I have a cold, so on and so forth. But the person will probably not tell you that I'm actually suffering from a certain disease. That is a doctor's job to tell the patients. And so this will be the idea that we have all the defects granularly, but then like from the defects, we can group things up and to become sort of like a road doctor, put it that way. First, select the road assets, find the defects and the repairs, find the causes and preventive treatments that are possible for the long term and not for the short term. Group the things into diseases. So when I say chesty cough, when I say fever, when I say sneezes, when I say all the symptoms, combined together, you might be having a cold. I'm trying to do this from the perspective of road defects, which I will illustrate to you in the next slide. And finally, to construct the relationships between each of the boxes, each types of information, and carry out sanity checks with overseas documentation. That's quite interesting because I was mentioning quite a lot from the context of the United Kingdom. But overseas, like there are loads of road maintenance authorities in various parts of the world, and very likely, even just for the English-speaking world with English documentations that I read, they will have different emphasis on their assets. So for example, in Australia, as I'm concerned, they care a lot about the vegetation and the prevention from forest fires, which is something that they actually put more attention on compared with the UK documentation on vegetation. So this is why I was having the sanity check. And finally, to map all these relationships in a network graph. And that's why analyzing the road conditions with a network thinking. It goes sort of like this. So I choose a patient, like an asset. I chose the luminaries. The name of it is important, but like it's street sign, basically. The kind of defects that can happen on a street sign are like lights are on when they shouldn't be on. Lights are off when they shouldn't be off. And there will be vegetation overhanging and obscuring the street lights in the place that we don't want. And obviously the light post, the lamp post could have been crashed or toppled by some impacts or so on. And so these will be the defects. I sort of alluded to have repairs on one end and causes the other end. Because I want to have the like-for-like repair. If you want a quick snap change the bulb. If the bulb is not on, then you can do that. Whereas if you want to do something longer term, for example, to understand why these kind of street signs or this kind of road lights would have problems for considerable length and with an aggregated like road sections, you can also do that with a preventative treatment style. And that's why you need to know the causes, so then you can actually treat the disease and not the symptoms. And finally, to group the diseases. So when I say lights are on when they're not on, lights are off when they shouldn't be off, then it probably comes into disease that the road light is not functioning well, malfunctioning, and that is the disease. And from knowing these things, we can actually find some solutions more categorically, more systematically. And so the network goes something like this. Identify the assets, luminary. I've got a network with the diseases in the middle, so aggregated electrical faults, damages, or so on. And on one hand, you get the quick snap repair. On the other hand, you get the causes. And so I'm sure that there are loads of discussions about how to find defects from various kinds of assets. But in this case, assume that you find it with whatever method, as traditional as manual inspections, as detailed as automatic detection with various kinds of computational techniques. Then manual functioning will be one of the cases that I found. And there are many causes. When you see something as having electrical faults, there may be lots of reasons why it has one. It can be poor design. But hang on a minute, because the lights weren't like that before. It was like running for 10 years, but then now it was not running correct. So design is probably not the reason. It might be about power supply, because the power supply is not stable, and that's why the lights are off when they shouldn't be. But then it will be something that you can check with the local electric supply company, and they'll probably tell you something about the conditions along the roadside that you want to investigate. A more probable reason is because the sensors are not working. So it's sort of some electrical or electronic failure that you probably need to act so that you can replace the sensors and then get the lights working as the way they should be. And finally, when you find the causes, you will go into the preventative treatments. What kind of strategies can you use next? Regular inspection, maintenance, testing, maintain in the way that it should. And finally, one thing is better reporting. Sometimes you don't actually need to have people to report to you, which is a conventional style in the UK to inform about the road problems. And that is sort of the situation that will have better reporting mechanisms by sensors or whatnot. And finally, just to conclude, different defects of many road assets. Road is not just the pavement. There are so many things around. And I've managed to map these into 15 diseases of defects with their relative short-term and long-term fixes. And that will benefit road maintenance as a system level and probably support some automation in years to go. So thank you very much for your attention, and I would like to give the time to the floor. Thank you.